Right now, the Sahara Desert covers 9 million square kilometers, nearly a third of the African continent.
Yet buried in its sands are hippopotamus bones, fishhooks, and spectacular cave paintings of giraffes and elephants, unmistakable signs that just 6,000 years ago, this was a lush savanna. During the last ice age, the Sahara had stretched even farther south, 500 to 800 kilometers beyond its present limit. Then a 20,000-year climate clock took over, turning the world's largest hot desert into a green paradise time and again.
The same clock is still ticking.
Around 12,500 BC, the first sign of a radical transformation appeared.
Scientists drilling sediment cores off the coast of West Africa noticed a sudden drop in the dust raining down from the Sahara.
For thousands of years, the desert had been pumping dust into the Atlantic, but now the dust signal collapsed, the monsoon rains had arrived. By 14,600 to 14,500 years ago, at the tail end of a massive iceberg discharge event known as Heinrich Event 1, the planet experienced a dramatic warming called the Balling Alarod.
That warming sparked the African humid period. The Sahara turned into a vast mosaic of grasslands, dotted with lakes and threaded with rivers. Lake Chad, today a shallow remnant rarely deeper than a few meters, swelled into a megalake the size of the Caspian Sea.
Hippos, crocodiles, and elephants roamed where sand seas now stretched to the horizon. The desert retreated, and a green corridor linked the Atlantic coast to the Nile Valley.
This wasn't a brief interlude, the humid Sahara persisted for more than 8,000 years. What makes the Sahara flip so regularly? The answer is written in the sky. Earth's axis is tilted, but it also wobbles, like a slowing spinning top.
This precession has a dominant 23,000 year cycle and a weaker 19,000 year cycle.
The wobble changes which hemisphere gets the strongest summer sun. When the northern hemisphere summer occurs near perihelion, the point in Earth's orbit closest to the sun, the North African monsoon intensifies dramatically.
That is the green Sahara switch. In 2019, researchers at MIT published a landmark study in Science Advances proving that the Sahara swings between wet and dry roughly every 20,000 years, driven by this precessional beat. The evidence comes from ocean mud. By measuring thorium-normalized dust fluxes in sediment cores from the West African margin, scientists reconstructed Saharan dust output over the past 240,000 years. The dust levels bounced repeatedly between lows of about 0.5 grams per square centimeter per thousand years and highs of 1.5 to 1.75, precisely mirroring summer insolation at 65 degrees north. When insolation peaked up at that latitude, the Sahara greened. The mathematics leaves no doubt, the desert breathes to a cosmic rhythm.
During the last green Sahara, humans flourished in an Eden that now seems impossible.
Imagine standing in today's Tenera Desert, a sea of sand, and plucking a fish spine from the ground. That is the reality archaeologists confront everywhere they dig. From the Tibesti Mountains to the Nile Valley, ancient hearths, grindstones, and human burials testify to a green world teeming with life. Rock art panels in the central Sahara depict giraffes, elephants, and even swimmers in what are today bone-dry canyons. Cattle herders moved their livestock across lush grasslands that now lie buried under endless dunes. This humid refuge stretched from the Atlantic to the Red Sea, supporting sizable populations for thousands of years. It profoundly shaped African cultures, and when conditions later soured, the survivors would carry that knowledge to the banks of the Nile, ultimately sparking the birth of ancient Egypt. Yet this green spell was not a fluke. Geologists have identified evidence for as many as 230 older wet periods, dating back perhaps to when the Sahara first appeared 7 to 8 million years ago. What we think of as a permanent desert is simply the dry phase of a repeating cycle, the arid breath between two green pulses. Around 6,000 to 5,000 years ago, the African humid period came to a sudden halt. A sharp global cooling event called the Peora Oscillation set in, weakening the monsoon and starving the Sahara of rain. The rain belts retreated south, and the green world disintegrated. Lake Chad shriveled from a megalake the size of the Caspian Sea to a shallow remnant. Grasslands turned to dust bowls, and the vast herds of cattle and wildlife vanished. In a geological heartbeat, the hyper-arid desert you see today snapped into place. Offshore, the dust sensors picked up the change immediately. Thorium-normalized dust fluxes surged back to their arid phase maximums of 1.5 to 1.75 grams per square centimeter per thousand years.
The Sahara was pumping dust into the atmosphere once more. For the human populations, this was an existential crisis.
They abandoned the drying interior and migrated towards the last reliable water source, the Nile River. The sudden concentration of people along the Nile floodplain, pushed there by the encroaching desert, created the demographic and social pressure that ignited one of the world's first great civilizations. As the sands advanced, the pharaohs rose. So the return of the Sahara to desert directly gave birth to ancient Egypt. The pulse that greened the Sahara last time has not stopped. Earth's precession continues its slow wobble, combining the dominant 23,000 year cycle and the weaker 19,000 year cycle into an average rhythm of about 20,000 years. The MIT study confirmed that no matter what else changes, this insolation-driven wet-dry pendulum has been swinging for at least 250,000 years. The geological record backs that up. At least 230 green episodes are preserved in the rocks, stretching back to when the Sahara first took shape 7 to 8 million years ago. We are simply in the dry slot of a cycle that has no reason to stop. Orbital calculations tell us that in the deep future, Earth's geometry will again favor strong summer sun over the Sahara. The same insolation threshold that triggered the African humid period will be crossed. When that happens, the North African monsoon will intensify, Lake Chad will swell back into a massive inland sea, and rivers that have been dry for millennia will flow. Hippos and elephants will recolonize the Saharan plain. The only uncertainty is not if the Sahara will bloom again, but what human civilization will look like when it does. The clock is already ticking towards the next green chapter. So the Sahara is not a permanent desert, it's a pendulum that has been swinging for millions of years. The same orbital machinery that turned it into a lush savanna as recently as 6,000 years ago is still in motion, governed by the unceasing wobble of the planet. The next green phase is mathematically inevitable, a future when the world's largest hot desert will once again bloom. It's a powerful reminder that the landscapes we think of as permanent are merely snapshots in a much longer climatic rhythm, and the next chapter is already set in the slow, steady precession of the Earth.